Good afternoon, everyone, and thank you for joining us for today's webinar. My name is Tejas Srinivasan, Brand Manager at Mobil for our mining sector, and I will be your host for today. Our webinar topic for today is on hydrogen as a potential fuel source to reduce emissions. A quick note, we will be recording today's webinar so that we can make the content available for those that could not make it. Before we get into our actual webinar, I'd like to take a second to talk about Mining into the Future. Mining into the Future is an event series hosted by Mobil Lubricants for the mining sector, where we bring together some of the most influential thought leaders from the industry, as well as from outside the industry, to talk about and break down some of the key trends that have the potential to shape the future of the industry. We do this through a combination of both in-person as well as online events such as this one. And some of you may have attended our latest in-person event that we hosted in November of last year in Tucson, Arizona. In these events, we cover a wide variety of topics shaping the industry, ranging from topics around sustainability, technological innovation, supply chain management, to workforce development. To learn more about Mining into the Future and to see our full calendar, please go to our Mining into the Future page. The link is on the bottom of the slide. Today, the mining industry faces seismic challenges as well as opportunities. The industry will have to dramatically increase the production of key minerals that will help societies transition to a lower carbon future. However, the industry is challenged with doing so, even while reducing impact to the environment. This will be one of the great challenges of the 21st century, and to overcome it will require technological innovation, both incremental as well as transformation. Today's webinar is a really special one because it is connected to this challenge. We'll have two experts from ExxonMobil's Low Carbon Solutions Organization, Alok Sarkar and Abhi Sanchez, talking to us about the potential for hydrogen as an alternate fuel source to help reduce emissions. Now, we've all heard a lot of noise about hydrogen and its potential, but it's not always easy to understand how to get started. Today's webinar will start with some high-level fundamentals and then zoom in on the potential for hydrogen's fuel switching as a way to help reduce fuel combustion emissions in your operations. We'll be doing a Q&A session at the end, but feel free to ask questions in the meantime through the Q&A tool. And with that, it is my privilege to introduce today's speakers. Alok is a fired equipment expert with 33 years of experience in the field. He's a principal engineer in ExxonMobil's technology and engineering organization, looking after emerging technologies in the fired equipment area, including fuel switching, new technology development, latest generation of burners, the use of AI and machine learning. He is a master's in chemical engineering from India. He's worked for 10 years in design and engineering and commissioning activities before he moved to Singapore as a senior combustion specialist in charge of a fleet of fired equipment in a large refinery. He then moved to the US and worked in a wide range of responsibilities, all in the fired equipment area. He has been with ExxonMobil for over 18 years, and in his free time, Alok enjoys traveling, listening to music, and doing a bit of gardening. Abhi Sanchez is the business development advisor for hydrogen in the Rockies and Permian area. She's a metallurgical engineer with degrees from the Central University of Venezuela, Complutense of Madrid, and she also has an innovation and entrepreneurship diploma from ATC Paris. In this role, Abhi has been leading our efforts to engage with different industries, including mineral companies and coal-fired and natural gas applications, to explore opportunities for emission reduction through fuel switching and fired equipment. In her 15 years of experience, Abhi has had a wide variety of roles within reliability engineering, supporting refineries, application engineering, market development, and business development, with assignments in Sweden, UK, Germany, France, and Indonesia. Before coming to ExxonMobil, she spent 3 years specifically focused on hydrogen and CCS applications. She is a native of Venezuela and is a naturalist by heart, and in her free time enjoys working in her farm with her husband Leonard, practicing equestrian sports and rescuing and protecting wildlife, including horses, foxes, raccoons, snakes, coyotes, and of course, dogs. Without further ado, I will pass it on to Abby to take it from here. Thank you, Abby.
Thank you for that introduction, Tejas. Well, we really appreciate everybody here taking the time to join us on this exciting topic. Um, this is a cautionary statement. I won't delve into the details, but you will have access to this in the recording. So let's jump to the agenda. As a recap of our agenda, in the next 30 minutes, we will be covering some of the basic fundamentals of hydrogen, introducing fuel switching, what it is, benefits, key considerations on existing and new fire equipment. We also provide an example of the impact in boilers and applications. We will get into the challenge and safety considerations that you need to be aware of. But the purpose of this webinar is to provide an overview of these topics rather than diving into deep technical discussion. If you are interested in exploring further into hydrogen portfolio or any other low carbon solution product, please feel free to connect with us. So let's go to the big picture. Every year, our world generates about 34 billion tons of energy-related CO2 emissions. And the mining industry plays a significant role, being responsible for about 10%. Of that, around 7% is released to the atmosphere. So just to give you a perspective, this is roughly equivalent to the annual carbon emission from around 74 million typical gas passenger vehicles. So in the chart on the left, we see emissions from different mining sectors, such as gold, iron, copper, nickel. This is a chart from 2019. I bet you are very familiar with this. The blue bars represent Scope 1 and Scope 2 emissions. Scope 1 refers to direct emission from sources directly controlled by the mining operations, like combustion fuel for machinery. Scope 2, on the other hand, includes indirect emission from purchased electricity or heat for the process. And the rest of the emissions that you can see there, the red bars, are associated to transportation and other downstream processing like melting and refining. But this is where things get interesting. Each mining industry has its own carbon footprint challenge, highlighting the need for tailored solutions. That will require some key considerations that you can see in the right and initial steps like energy efficiency equipment, optimization across the stage of all the mining operations, explore integration of hybrid power. So it means combining renewable sources with traditional power generation, transition to alternative vehicles, and explore opportunities to adapt the mining process, which sometimes will require retrofits on equipment to utilize clean fuels like hydrogen. But the key message is by understanding the scope and distribution of those emissions, you can start to pave the way for the most suitable path. Now, let's start to talk more about the role of hydrogen in mitigation, in emission mitigations. So ExxonMobil, at ExxonMobil, we're color agnostic when it comes to low carbon hydrogen. All types of low carbon hydrogen are needed to help to achieve a net zero future. Depending on where your facility is located, one form of hydrogen may have an advantage over the other. We offer different solutions based on customer needs, and this is validated through a carbon emission reduction assessment that our technology team does. I bet you have seen different colors, and sometimes this can be confusing, but it is pretty simple, actually. The color classifications that you can see in the top and the bottom are related to the energy sources and production methods. Blue hydrogen in the top. Here, natural gas is used, and the hydrogen is obtained through steam methane reformer processing. In the outcome, you will have hydrogen and CO2. The CO2 will later be captured and storage. The second option, the turquoise is also obtained through natural gas as a source, We do thermal decomposition of the natural gas or the methane. Here the products are hydrogen and solid carbon. As a result, the CO2 release is prevented and it does not require carbon capture storage. In the bottom, you can see green and pink via water hydrolysis and can be powered by renewable in the case of green and nuclear in the case of pink. The right production method or hydrogen color will depend on different considerations. You will need a thorough assessment of the process you intend to reduce emissions to determine which option could be the right fit for your process. In the next slide, I will show you more about what are we doing, which is ExxonMobil position with hydrogen. And just to give you some background, hydrogen is not a new business for ExxonMobil, right? We have done this for decades. So today, ExxonMobil is one of the largest hydrogen players in the world. We produce and consume more than 1 million tons per year in our refining and chemical operations. We're taking our learnings on the use of hydrogen in industrial facilities for our own scope. We're working with the customer on best practices. In that way, we're trying to, and we're looking to ensure that their demand can meet reliable with our low carbon hydrogen supply. We're expecting to make final investment decision by 2024 this year. And producing low carbon blue hydrogen in Baytown plant could reduce the site CO2 emission by up to 30%. Blue hydrogen at Baytown will support our ambitions of achieving net zero 1 and 2 scope across the operate asset by 2050. We plan to produce up to 1 billion cubic feet per day of hydrogen made from natural gas and expected to capture 98% of that associated CO2 to be stored underground safely. This project could be the lower carbon hydrogen plant in the world at the time that we're planning to start up in 2027, 2028. So please stay tuned with this project. For now, I will hand it over to Alok Sarkar, our fire equipment expert. Alok will take us through the topics of fuel switching and implications. So Alok, please.
Thank you, Abby, and thank you, Tejas. Now the fun begins, right? But before that, special thanks to all the audience here. I appreciate your time. Good morning, good afternoon, and good evening, considering this is a global audience in here. And the audience is pretty wide in terms of the disciplines and the work activities. Even though my topic could be a lot technical, and we have done significant amount of work in this hydrogen fuel switch, or LCS to begin with. Hydrogen fuel switch is a portion of that. So the challenge would be to state the fun facts within the short time, and I will do my best to stay within the time limits. But before that, let's start with a poll question. So what color is hydrogen? Thanks to Abby's education, let's see what answers we get on this trick question. I see all of the above, none of the above are leading. Okay, the numbers have kind of settled out. A few blue, a few green. Okay, I think we can share. So basically 40%, 45% are all of the above and none of the above. The answer is actually all of them are true, right? Chemically, the hydrogen has no color, but the way you produce, we assign it a color. So all of them are correct and none of them are correct. Actually, it is colorless. With that, let's get into the technical topic here. As I said, we will look through the highlights of the technology and not go too much deep in detail. But again, as we mentioned that Q&A session, please lodge in your questions in there, and also in future we'll be able to answer whatever questions you might have. So with that, hydrogen fuel switch, what it is? It is what it means literally, that you switch fuel from one fuel to hydrogen. Fuel switch has been happening over 3 decades. The boilers and fire equipment has been changing from coal to natural gas to other fuel gases. So that's what it is. The pictures kind of give a very simple idea of when you are warming your hands in a winter morning or using a barbecue. It's the heat that you're looking for, not how the heat or where the heat comes from. But eventually, where the heat comes from has its own GHG, the greenhouse gas impact on the carbon dioxide emissions. And that's where the fuel switch becomes more interest in here. On the next slide, it talks about why consider fuel switching. It's a concept, it's an idea, it's an aim that you are attending this webinar to learn more about it, but we know the objective. If you look at the picture, the sketch on the right side, you have this coal-fired boiler that's taking coal from a mine and then goes to the boiler. The boiler makes steam, and the steam makes power. In some cases, the steam is being used to heat up some process. The aim here is to basically reduce the carbon dioxide footprint of the fuel. So that's why change from coal to natural gas gives you a reduction in carbon dioxide. Go from natural gas to another low intensity, low carbon intensity fuel, and then you go all the way to hydrogen. Now you're not making any carbon dioxide. So that's the consideration. So in the current world aim that we are trying to lower emissions, and the ambition for net zero target is accelerating this transition a lot more. There are low carbon initiatives, and the organizations are trying to go there. There are conversion incentives like the Inflation Reduction Act. The state governments, the local governments are giving benefits. It's there globally, Europe, Canada, and Asia. So it is not just reducing the fuel, there is also an economic advantage to going to do the fuel switch. As I mentioned, the concept is nothing new. It's just going one step farther, particularly when you're going to 100% hydrogen or 95% hydrogen, very high hydrogen. On the next slide, talks about what are the areas you can do fuel switch, and actually it can be anywhere. When we say fired equipment, meaning it's an equipment where you are burning fuel, or in other words, where you have a flame inside, and that heat delivery system is there. You are just changing the heat source from one source to another source, and the objective is to go to low carbon source, right? Industry type, I would not go through all of those. It's quite common sense. You've got electric plants, you've got industrial sites, whether it's a petrochemical or a refinery or mining industry, steel, cement, can be anything. Universities, colleges, healthcare, hospitals, so they used to have decades back coal-fired boilers, and they are now all transition into natural gas. So now we're talking about maybe go to 100% hydrogen. Are there any other alternates that can make it low carbon intensity? Now, applications. So even though you talk about industries, where does the fuel go into? So the applications are fired heaters, reaction furnaces, and these are the heaters where you heat a process fluid, something like in the refinery or petrochemical industries. And then you have boilers everywhere. You need steam for heating or for power. You have cogeneration systems where you make steam and power. And then incinerators, thermal oxidizers, calciners, more common in the mining industry. So this is where the fuel is being burned. Now, burners per se is not really an application, but this is where the fuel is being burned. So whether it's a fired heater or a boiler or an incinerator, you have a burner or sets of burners, and that's where it sees the fuel switch. So of course the burner has to take it, but in addition to that, the downstream system, the auxiliary system, the fan, the induced or forced draft fan that you have, the treatment system, the emissions, those also have to manage and handle the fuel switch. A bit of middle school or high school chemistry here, and this is to emphasize why the fuel switch is not just a fuel transition, right? Take a look at the chart, and again, we'll stay very high level on the chart. If you look at the chart, on the x-axis is hydrogen content in fuel gas. So you see on the left side goes from 0% to 100% on the right side, and then it's comparing the airflow demand and the flue gas flow that it generates. Flue gas meaning fuel and air combustion product, right? So you see that as hydrogen goes from 0% to 100% in fuel, the air demand actually comes down by about 15%. The flue gas flow volume basis increases by 5%, but the flue gas flow mass basis reduces by 17%. So it is not unidirectional change. Bottom line, you have to look through the equipment where you're firing that fuel to see overall impact of the fuel transition. Look at the bullet points on the left side. Hydrogen heating value is about 1/3 of natural gas on volume basis if you're burning 1 standard cubic feet of hydrogen versus natural gas. But if you're doing on a pound basis, mass basis, it is 300% of natural gas. The other way around. Hydrogen flame speed is almost 10 times faster than natural gas. Hydrogen actually burns 400 degrees Fahrenheit hotter than natural gas, and that causes the NOx emissions to go up, right? So these consideration changes what your fired equipment will behave when you do the fuel switch. If you go to the next, yep, there. So what you see, the fuel volume goes up by 300%, fuel mass goes down by 60%, air demand drops, and that has to be addressed when you're switching from existing fuel to hydrogen fuel. And by the way, it's not just switching to 100% hydrogen. Very likely you want to retain the possibility, the feasibility, the provision that you can fire back the natural gas or whatever you're firing today. So you want the full flexibility. One fun fact here that you will see on the chart with the dashed vertical line, the red line you see around 85 or 90% hydrogen, is that at that point, when you are going from 0% hydrogen to about, let's say 90% hydrogen, you get carbon dioxide reduction of about 50%. So it's not 1-for-1, meaning if you want the bang for your buck, you are aiming for higher hydrogen. That will give you the most impact for your change. Moving on. So when you do the fuel switch, what are the considerations to be taken for the fired equipment? And again, this is a fired equipment, meaning it can be a boiler, it can be a heater, it can be a thermal oxidizer or a rotary kiln or whatever system that you have. And obviously, it depends a lot on what the existing equipment look like, right? If it's a very old coal-fired boiler, then obviously the changes are expected to be much more than if it's a natural gas-fired boiler designed 3 years back. What type of burner does it have? What type of air delivery system does it have? So all those factors are important. On the next slide, you see an example for a boiler. So the column on the left side is for a new application boiler versus on the right side is a retrofit application. On a new boiler, there are actually existing boilers firing 100% hydrogen. So it's very well understood. There are technologies available to manage the emissions, and you see the impact. The designs can be managed on the get-go because it's a new design. You can make the boiler give you what you want, and the cost for implementation is relatively minimal. However, on a retrofit application, as I mentioned, that it depends on the vintage of the design, right? So that's why it depends on case-by-case basis. However, there is no technology barriers. It's all about how much money you have to invest. And how much money you have to invest depends on case by case basis. What are the changes that you have to do? But it can be done. Want to draw your attention on the pictures you see on the right side. Coal flame is bright. It radiates a lot. Natural gas, bluish flame, like what you see on the stove, it's more of, you can still have radiation from the flame. Hydrogen is very transparent. I mean, it does radiate, but the emissivity, it's a physical characteristic of the flame, changes significantly from coal to natural gas to hydrogen. And those are more the inside the engines, inside the hood, that you have to consider when you're looking through the transition. For interest of time, I will move on to the next slide. Just to mention to you that the industry as a whole, and particularly we at ExxonMobil, have taken this fuel switch very seriously. We are assessing our equipment, fleet of thousands of our equipment where we are planning. And this is one example where ExxonMobil and Zico, one of global burner suppliers, leading suppliers, we have worked together hand in hand and come up with this design where the latest generation of burners in a fired heater, what you call the ultra low NOx burner, or ULNB, we have gone one step farther than that. So what we are calling as next generation ULNB. And this design, we worked with the supplier and we have come up with a design. You see the pictures on the bottom right with 100% natural gas, 30% hydrogen, 80% hydrogen, and 100% hydrogen on a wide variety of process conditions: forced draft application, natural draft application, preheated air, ambient air, low BTU gas. So we have done a thorough testing of that burner. And then we installed those burners that you see at the middle cell of 12 burners in a circle, been in operation for a few months, and it has exceeded our expectations. If you look at the chart very quickly, the existing ultra low NOx burner versus this burner gives you the reduction almost cuts into half. And this is an example. We also have steam cracker burners with our own proprietary design. And the point here is to say the industry has moved on, and there are few leaders in the industry where we're moving on faster than others. But the technology is available if you want to switch now. And then the next slide. This is my final slide. And as I said, that there has been so much learning from our side. We would like to talk a whole lot, but in the interest of time, I will hit a few important highlights. We talked about the large difference in fuel properties, right? Hydrogen versus natural gas. And even though I talk about natural gas many times, it can be a mix of any gases, right? And the refinery fuel gas or a low BTU gas, whatever that is. But the properties are so different. You have to think through not just the fired equipment, it's also how you deliver the fuel and how do you manage the transition when you go from natural gas to hydrogen, or hydrogen to natural gas if that is the backup fuel, right? And it can be done. In fact, within ExxonMobil, we have in our refineries fired heaters or fired equipment operating today and last few years with as high as 70% hydrogen. So we are just upping the challenge by a notch. It's not unknown. We are going to be a little better than what we have done before. One last item, I mean, there are lots of considerations. One last item I want to leave with you thinking is the point, the robust safety, protection, and control system for fuel transitions. That's the safety aspect you have to consider thoroughly when you are considering the fuel switch. What that means is when you are firing on hydrogen, and let's say there's an interruption of hydrogen supply, natural gas kicks in. Hydrogen being a low molecular weight, large volume, natural gas, when it kicks in, it can actually put in too much fuel into the heater. How do you manage and mitigate that? right? So that transition is extremely crucial for safety of your equipment. As I said, we have done this and it can be done. It needs good, accurate measurement systems and control systems that will work on feed forward and not feedback system. So these are all very well understood and can be done. But this is a very key step that you have to consider and manage when you do the fuel transition.
If you'd like to learn more about the work that the Low Carbon Solutions team is doing in the hydrogen space and beyond, please feel free to check out their website. If you have a question for the team that you were not able to get in today, please go on the link that's listed here. It should pop up a contact us page that the LCS team will be monitoring and answering for you. If you'd like to meet us in person, we are going to be at MINExpo in September. The Mobil team, along with the Low Carbon Solutions team, will be in Vegas in September at MINExpo. We'll have our booth there, and we'd love to meet you all in person if you are planning on being there. And we will also make a recording of this webinar available on our Mining into the Future page for anyone who missed this. This concludes our webinar for today. Thank you again for making time out of your busy schedules to be with us. We really, really appreciate it. Huge shout out to Abby, Alok, and Nathan, and the whole Low Carbon Solutions team for putting on this webinar for us. Thank you. Hope you all have a wonderful rest of your day. Thank you, and see you soon. Bye.
Thank you.
Thank you, guys.